Hello everybody, I have a bunch of random junk from my piles, so obviously we are doing a project. As this is an electrical channel at its core, I am returning to do a electrical project, oops, I'm knocking stuff, for this week, and the van series will be returning in due course for anyone who is following that, but I'm trying to intersperse some of the more technically electrical stuff for those of you who care about this and not the vehicle related content. Anyway, with that out of the way, what am I making? I am making a isolation transformer, which I'm going to quickly explain what that is for anyone who is not aware, and we will return to this in a second, and I'll show you the part and the plan that I have come up with as to how I'm going to assemble these bits. I'm going to have a second attempt at explaining this because I took ages the last time and waffled on for ages. So, what is an isolation transformer? An isolation transformer is a safety device. As I will say, it will reduce the risk of electric shock. One thing that is extremely important is an isolation transformer does not and will not prevent you from getting a shock. I cannot stress that enough. It does not make you immune, it just makes the risk reduced. But again, actually, something I probably should have said last time, is it will prevent GFCI's RCDs from functioning too. I'll explain why. But in the electrical supply, your supply originates from a substation. That will have a winding like this. In the UK, we have 240 volts across this winding from there to there. We name one of these live and one of them neutral. So let's say that's live and that's neutral for the sake of argument. You then have the actual Earth, which is the dirt that we stand on, the planet Earth. They have a neutral earthing, it's actually a resistor. I am resisting going into depth about such things because that's what happened last time and it took ages. You have a neutral earthing resistor, but for the sake of simplicity, link. It can be a reactor too. Again, I'm not going to get into that. Link. That goes from the neutral to a lump of metal which is just in the earth. Usually it will be an earth grid for a substation, but again, I'm not going to get into this, keeping it simple. That means that you then connect the neutral to Earth. This is why people go, oh, AC polarity doesn't matter. Yes, it does, and this is why. If you touch the neutral, you shouldn't. I will stress this. You should under no circumstances touch a neutral. It is a live conductor. But it is usually, provided everything is working, very close to Earth potential because they are connected at the substation. So, but the live is 240 volts above neutral, so you have 240 volts between here and here. Which means if you are unfortunate and you're standing on the Earth, so you're connected here, and you touch that, you'll get a massive shock. What an isolation transformer does is it basically gets rid of this link. So you connect the output of this to another coil, and then this coil magnetically couples to another coil. So we have 240 volts in, and most transformers change the voltage. These ones don't, they just pass it through. So 240 volts out, but no link. So that means if you're standing on the Earth and you touch that, you won't get a shock. If you're standing on the Earth and you touch that, you won't get a shock. It also means that you can connect measurement equipment to things and it will not blow things up by accidentally putting mains across your test equipment. But again, you have to be very careful with such things. You can accidentally reference things to things and it can cause problems. Again, keeping it simple, not going into that. So yes, it will prevent you getting a shock between the Earth and either of the live conductors. But another thing which is worth bearing in mind, if you touch both of those, you will get a shock. And a RCD or a GFCI will not work. Again, RCD, GSCI, keeping it very simple, the way they work is they measure the amount of current which flows out on the live and back on the neutral. So if you get shocked between live and earth, the current will flow out the live through you to earth, back to here, and then up to the neutral through the earth. The RCD is measuring the current here and here. So because the current is bypassing that, it's flowing like this, the RCD will measure current flowing here and not returning here, and therefore it will trip. If you touch between here and here, as far as the RCD is concerned, the current is flowing out here, through and back round again. It will measure it both sides and it will not trip. So that is something to bear in mind. You should not, again I should probably have said this before, you should not under any circumstances be messing with any sort of mains powered equipment unless you know exactly what you are doing, because it can be very dangerous. One other thing I'm going to quickly mention while I have paper here to explain it is the concept of a split secondary. This will be more familiar to the Americans, where they have on their substations an arrangement like this, where they earth that bit in the middle, and then they have a 110 volts here and 110 volts here, and 220 volts between 220 volts between here and here. The concept of a split secondary is the same. The isolation transformer I have has a split secondary. So you have two windings on the output. They are 120 volts each. And you can either connect them in series or parallel them to get 240 volts or 120 volts, depending on the purposes you would like to use it for. But yes, I've waffled on enough. Let's get on to the actual interesting part of this, which is the project building. So this is the core of the project. This will be quite familiar to those of you who live in the UK, probably not to anyone else, because this I think is unique to us. I don't know if anyone else does this. Our building regulations and our electrical regulations are very strict about electricity in bathrooms and areas with water. And back in the olden days, before battery shavers were practical, they used to have shaver sockets like these. As you can see, it says on it, if it will focus, there we go, shavers only. So these would be mounted next to the sink in the bathroom in order to let you plug your shaver in to shave, and you can use it to like plug your toothbrush charger into now, although these are being superseded somewhat by basically toothbrush chargers that attach in the same form factor. Anyway, again, I'm getting off topic. I'm bad for doing that. This thing would be used in the bathroom to prevent the risk of shock, because it is an isolation transformer. If you flip it over, you will see here, big transformer, and up the top, 220, 240 volts, 20 volt amp. 20 volt amp is the way that you would express the size of load a transformer can carry. 20 volt amp means 20 volts times amps rather than watts. It's slightly different because of power factor and AC weirdness. Again, I'm not going to go off topic and do a big rant about this, but just know that 20 volt amp is basically 20 watts for all intents and purposes. So this is fairly small, but for things like small switchable power supplies, which I would be using it for, this will be perfectly sufficient. This one is an MK branded one as well. These are fairly decent. There are many other brands though. I removed this from a client's premises because they had damaged the cable and didn't want this anymore, so we just removed it, and I kept it for the transformer, which I will remove in a moment. Another quick thing I will mention while I'm on tangents is you'll notice there are two sockets. That's not for simultaneous use. You can't actually read it very well, but this one says 115 volt and that one says 230 volt. which is designed so that you can have a 115 volt or a 230 volt shaver, both of which were sold in the UK, so we do actually use 110 volt or 115 volt sometimes. Another thing of note with these is you will see two things. The pin sizes are different, so you cannot accidentally plug them in the wrong way around. And there are these cunning little slots here, which are designed so that if you have a American NEMA plug, you can plug it into a 115 volt shaver outlet in the UK and it will work fine. And these ones here are for an Australian plug, so you can plug an Australian plug into this one and it will work fine. For something like a phone charger, that will be perfectly fine, but again, they're limited to about 20 to 40-ish watts, depending on the manufacturer, so don't be stupid and go plugging a kettle or something in. Yes, I'm going to stop waffling about shaver sockets now, and we'll get the transformer off of this. It should be fairly straightforward, just a few screws. There will be a switch in here actually to connect the transformer or disconnect the transformer, which is to basically prevent losses from having a transformer sitting connected to the mains all the time when it is not needed. But yes, we will take these screws out. I need to get a screwdriver. So I have the bits. You'll be able to see more clearly now the transformer is out. The 2 input terminals on the primary side and the 3 outputs on the secondary side, as I was talking about earlier. So you have 240 volts between these two here, and then 120 volts, 120 volts and 240 volts there. The other bits I have are just some bits I had lying around to try and make this work. I have a plastic ABS box. I'd recommend you get yourself some of these. They're very useful to just have for things like this, which does happen to fit rather neatly the transformer inside it, which was why I chose this one. So that's going to be our enclosure. I have here a switch. This is actually an industrial panel switch, but again it will do for this. I'm going to use this as a changeover between 110 volts and 240 volts to switch over between the two of them. This is actually a normally open and a normally closed contact block, but I'm going to just common two sides of it, so you'll get basically a common and then a changeover between these two here. Anyway, again, the other things I have, I'm not sure if we'll use. I have a couple of these speaker terminals here. These are obviously rather dodgy, but I'm taking inspiration from, if I bring it in, the hoppy meter, which I'm sure many of you will be familiar with, and it's rather useful little speaker terminals. So I figured I would throw a couple of them on because they're small. And another thing I have is a small panel mount socket. Again, somewhat questionable because it doesn't actually have the shutters that it should, but again it will be about the right size. The other thing I might do, I don't have one on hand, but if I can't fit all of this on this box, I will just put a second flex out, and then we will connect on that flex a socket just on a box. But that will see if this will all fit. What I'm going to do now is I'm going to see if I can lay this out, and we'll put some holes in the box. And I will get back to you in a second with the box all hauled up so that we can mount our things into it and get on with the wiring. So here is my box with all my holes drilled in it now. I have my holes up here for this with the holes to put some screws into. I have a hole here for the switch, and one thing I will quickly mention for any of you who are not familiar, these are industrial panel mount switches. This is a very common design. There is a set of contact blocks which are interchangeable. I'm not going to take these off because I don't want to put them back on again. It can be a little bit fiddly. But you have a set of contact blocks, and then the actual switch mechanism on the top just actuates contact blocks. So if you press this little white tab here, that will pop out, and I could put a push button in here, a latching push button, non-latching, whatever I want, the same as how I could take this switch and put that onto any set of contact blocks. So like for example, if I get it out the bag here, there is same setup, but this one is an emergency stop button. I could take this head off of here and put it onto that base, theoretically speaking, if they were from the same manufacturer, which they are not. But most industrial panel mount switches will work something like that. There will be a removable top part and a bottom part. They are keyed as well, so you can't put them in backwards. But this bit here, I then have a lock ring I can unscrew off the back. This goes on the panel, screw that in, and then you attach that on the back of the panel. I'm going to get on with wiring this now. Oh, one other thing I should have mentioned if I didn't already. I put a little flex outlet on here as well. Put a hole through the side, so that means I can take my flex in, strain relief and stuff. And I also made up a little LED indicator, mains indicator. If people are interested, I can make a video about various ways to drive LEDs off of the mains. But yes, I'm going to get on with wiring this now, and we'll have a look at the internals and how to do that. And here it is finished. I'm just going to quickly show you the wiring so we can understand how it works. And then I'm going to put the top on it and we will be done. I'm not quite finished because there's a couple bits I would like to add, but I don't have the parts to do it right now. And this video is supposed to be coming out in a few hours time, so I'm just not going to do that because I want to get this out and I'll add them in later. But we have incoming in the side through the strain relief gland a flex 3-core. The live and neutral go onto the primary of the transformer. The earth goes into this split here. One leg of that goes onto the transformer chassis, which is to earth this. It helps with interference. And also this transformer is supposed to be earthed, so I'm going to earth it just as a sort of fault protection thing. I think it's supposed to help with interference actually. I might be talking rubbish. Don't know. Anyway, I think it does. But we have on the output of that 3 wires. This blue one is not a neutral. I'm just differentiating between the switched legs and the unswitched one. This is one extreme end of the winding. Then these 2 red ones here, one of them is a centre tap and one of them is the other end of that winding. They come into this switch, one into each side, one normally open, one normally closed. On the other side of the switch I have a link bridging the 2 together, and then that comes out and feeds the live to my thing, my socket and my speaker terminal. Again, it's not actually live because it's isolated, but again, I'm treating it like this for simplicity's sake. Basically, the way this works is when this is closed, it will come through here, through this, so normally closed. The power will come from the centre tap through here, through here, through here to here, and we have 115 volts here. And then if you switch the switch, you will open this and close that, and you'll get the other end comes through again through here to here, and you get your full 240 volts out the other side. The thing I want to add, my camera battery is going flat as well, so I better hurry up. The other thing I want to add was a switch to break the earth, so you can decide whether you want the chassis of the thing plugged in earth or not. I don't have a switch to do that with, but it will go here just underneath that one when I add it. The other thing I need to do is I need to get some bolts to actually mount this transformer in place properly, but again I don't have any to hand. I'm going to have to go get them, and I want to get this finished. So I'm going to get the cover on this and I'll show you it working one moment. So that's it together. I have my multimeter probes in the speaker terminals. Multimeter is set to AC voltage, and I'm now going to reach back and turn it on. And we have there 136 volts, and that blue indicator has come on as well, which is good. The reason the voltage is quite high is because there is no load on the transformer at the moment, so the voltage will drift up. As soon as you start to draw current from that, it will drop down. And then if I turn this round, we have 278 volts. Again, that's quite high because there is no load. As soon as this is loaded, that will drop down. Actually, I might see if I can show you that. I have here my charger for my camera. I'm going to turn this down to that just in case I damage things. So when we plug that in and I then stick a battery onto charge, you'll see that voltage is falling when I start drawing significant amount of power from it. So that is why it happens. If I then turn this up to 270 volts, that's actually not falling as much as I thought it was, so I'm going to turn it back so I don't damage things. As I was saying, that is quite significantly over the rated input of this. Anyway, that all seems to be working. The other thing I will show you quickly, if I just unplug this, is that if I take my meter probe out of there and I stick that onto Earth, there is a negligible voltage, and again if I change it, there is 8 volts. Again, minimal. It'll be jumping around all over the place because they are not referenced. But it is not the full 240 volts, therefore it is not as dangerous as it might be. So yes, I'm happy with this. It is a useful little thing. I'm going to add a second switch here to break the earth to this socket. When I get one, I'll have to order one in. And yeah, useful wee thing. This will probably be refeaturing again in the future when I'm doing stuff that involves probing on switch mobs. Hopefully I'll be able to show you some waveforms on oscilloscopes and such like in the future because of this little thing here. So thank you very much for watching, and I will see you all next time. Bye!